Okay, so welcome back, and right now we're going to take a look at ideas of cell potential and concentration, but we're just going to look at it qualitatively. We're obviously going to be using numbers, but we're not going to be calculating actual results for cell potential when concentration is not standard. We're just going to take a look and see, do we think things should increase or decrease in terms of the cell potential result? And what we can do to make this determination in a qualitative way is make use of Le Chatelier's principle. And so in order to do that, we have to know what the usual conditions would be. In standard conditions for concentration are 1 molar. So when you're getting a standard cell potential, you're assuming that it was a 1 molar solution for any of the ions that was being used. Once we have that, we can make a comparison, and from there we just need to figure out what direction of reaction is favored by changing the concentration of an ion. So one thing we need to remember is that cell potential is essentially electromotive force. It's the force that's going to push electrons through through the cell, through the wire, through the system. You can use any one of those three terms in terms of how you want to think about it, but it's basically a push. Okay, and so the idea here is the change that we're going to make going to increase the ability to push, or is it going to decrease the ability to push? And typically what we would say is that if Q is less than K, the system wants to move to the right, and to the right is the direction that helps push electrons through the cell. So the more that we can encourage a shift to the right or towards the products is going to help push the electrons through the cell. However, in a situation where Q is greater than K, now we have a situation that's working opposite what's going on. And so while electrons are going to get pushed through the cell by turning reactants into products, when we start pushing back against that by turning products back into reactants or not allowing maybe the system to be where it is, there's going to be a resistance to the push of electrons through the cell, which would decrease the cell potential. So a quick way to think about that, I've got 2 reference points here. Typically increasing the reactant concentration will increase potential. The other possibility is decrease product concentration also will increase the potential, or increasing the product concentration will decrease potential, or a decrease to the reactant concentration will also decrease potential. So as we're looking at this stuff, it should be a real easy inspection here. We're going to assume that the cadmium ion is still 1 molar because no mention has been made of it in this question. But it says, based on the following cell reaction, what will happen to the cell potential if silver ion concentration is increased to 1.2 molar? Well, silver's a reactant. Its concentration has been increased. And according to this bit of information, increasing reactant concentration is going to increase cell potential. So we would expect cell potential to increase. Next example problem we have here is same balanced equation. What's going to happen to the cell potential in this case? Well, again, we're going to assume that without any other mention, silver's concentration should be 1 molar. And in the case of cadmium, we're talking about 2.3 molar. So we have a product concentration that is increased. And according to this bit of information, increasing product concentration is going to decrease cell potential. And we got our next 2 examples shown here. And so in this case, once again, we've got the same balanced equation. We can assume 1 molar for cadmium. And in the case of silver being a reactant, now its concentration has decreased. So we go back up and let's see. Again, if we decrease reactant concentration, that will see a decrease in the cell potential. And so, in this case, we would expect cell potential to decrease. So the last example problem is same balanced equation, and once again we're looking at our silver ion concentration as being 1 molar because there's no mention otherwise. But in this case we have a cadmium ion concentration of 0.97. And so as we're looking here, we're going to see that decreasing product concentration, as we mentioned before, will have the effect of increasing cell potential. And so we would expect to see the cell potential increased. Now, because that's a really small difference compared to 1 molar, the increase that we're talking about is going to be very slight. But that's essentially the work that you're going to do to make a qualitative inspection of whether or not cell potential should go up or down. So, hope this helps. Good luck putting it to use for yourselves.